Hi everyone, this is Vuse, and I'm coming again with another video. So we are still continuing with our series on vectors. So we're still dealing with concepts. So we're going to do this for a few months. We're just gonna go and just deal with concepts, all the concepts in physics. So my aim is to just cover everything basically. So it will take me a few months to do that. Where you're covering everything from just the start of physics to the end of physics. We'll probably even get to cosmology and astronomy and all of that. So I'll still decide if we're gonna get there. But then we're doing it the algebra way. We're not using calculus. And then after doing this, when I'm done with this series, and then I'll introduce problems, and I'm done with problems, and then I'll start introducing calculus-based physics. And then somehow I must start doing maths as well, so that I just help as many people as I can. Okay. So that's the purpose of the channel. Otherwise, if it's your first time joining us, please do subscribe. It helps a lot if you do subscribe. And then also there's a bell notification thing there. It's a bell shape, and then you just click it. And then it allows you to get notified whenever we post a video. All right, so now what we'll be looking at, we did on a previous lecture, we covered the situation whereby we are adding vectors that are in the same line that are collinear. Now what happens if they are not in the same line? Well, there's two ways now we can add them, right? So the first one, we'll look at it, what happens when they are perpendicular to one another, and then what happens if they are not perpendicular to one another. They're just at an angle to one another, and then how do we go about adding those vectors, right? Then after that, we're going to extend everything. So you'll see, just make sure that you follow the sequence of the lectures so that you don't miss out or get confused somewhere. All right, now let me draw a Cartesian plane. There's a Cartesian plane, and there's a reason why I want to do this, because I want to specify a few things. All right. Okay, so you've seen me doing this thing whereby I use this x hat thing and I use this y hat thing. Now the question is, what is this thing? Well, the x hat and the y hat are basically called unit vectors. X hat is a unit vector that is facing in the x direction, and the y hat is a unit vector that is facing in the y direction. Now, what is so special about these vectors is that they don't have any dimensions. So it's not like you say 1 meter or whatever. They don't have any dimensions, and their magnitude. So whenever we talk about the magnitude of the vector, we are going to use this sign. In mathematics, this is an absolute value. An absolute value is a value that is generally always positive. So you're making it positive, right? So there's an absolute value. So when we do this, when you see us doing this, some people or some books will see them doing two signs like this. They are saying the magnitude of whatever is inside here. And remember what the magnitude is. The magnitude is the size, right? So the magnitude of a unit vector is always 1. So the magnitude of y, I'll just use 1, is also 1. So a unit vector is a vector that is just pointing in a particular direction. In this case, the unit vector x hat is pointing in the x direction, and then this one will be minus y hat, and then this one here would be minus x hat, right? So these are just unit vectors. So whenever I use this one, so what I'll normally do is I'll just write them somewhere here to show you that I'm choosing x as positive going in that direction, and I'm choosing y going in that direction as positive. By the way, you have a choice to say which direction you want to take as positive. You are not forced to always take this direction as positive. But then when you do change them, make sure you are consistent in your workings. Now, my advice to you is don't confuse yourself. Always choose them like this and then just work from there. So what I will do in this series, in this physics basically series or course, whichever way you want to think of it, is I will always keep them positive like this, and then I will only change this if I feel it's convenient for me to change, right? But then I can still just keep it like this and still work out everything, right? So that should be fine. So these things are called unit vectors. That's the most important thing. So I wanted to introduce that one. That's why I said I would explain them later. All right. Okay, now let me just erase. Maybe the eraser is going to behave this time around, and let's see if it's behaving. It seems to be behaving this time around. Okay, so that's good, and it has to do with my computer. The app itself is quite good. I've been using it on another laptop. It has been working quite well. So it's just that the laptop that I'm using now, I think that it's the one that is a bit slow. All right, so that's fine. I'll get that fixed over time. That's okay. That's not a problem for now. Okay, now, so let me say you have a vector, and one vector, let's call this vector A. You have vector A, and vector A is in that direction, and this is vector A, and that vector A, let's give it the magnitude of 30 meters. I'm going to use meters because it simplifies my life, right? I don't want to change units. Now and then, let me say I have a second vector, and the second vector is vector B, and vector B is in that direction. And this is vector B, and vector B, let's give it 25 meters. All right, so these are the two vectors. So we can all agree that these two vectors are perpendicular to one another. So meaning that the angle between them is 90 degrees, and that's what perpendicular means. It means that the angle between the two vectors is 90 degrees. Now the question is, how do I add these two vectors, right? Now the nice thing about vectors is that you can move a vector. For instance, if I draw another vector that starts here, I draw it, and then it stops where B stops, and it's also facing up. This vector is still the same as B. So meaning that I have actually just translated B from this position to this position. I have not changed anything. So the magnitude is still the same as that of B. The direction is still the same as that of B. Therefore, it's still the same vector, right? So we talk about the equality of vectors. We say, now, vector, for instance, vector, whatever vector, let's not call it A in this instance because I have A already. So vector C is equals to vector D if the following is true. If the magnitude of C is equals to the magnitude of D, and the direction of C is the same as the direction of, is equals to the direction of D. So if they are facing in the same direction, they have the same magnitude, then these two vectors are actually equal. That's what I mean. So if they have the same magnitude, but they are not facing in the same direction, they are not equal, right? And that is very important. So if I have another vector, so let me say I have a vector D, okay? So I have a vector C, right? Now, and then this is vector C, and I say vector C is 20 meters. And I draw another vector, and I say this is vector D. But I also tell you that vector D is 20 meters. So you can all agree that the magnitude of C is equal to the magnitude of D. Remember, when I write it without the arrows on top, I just mean the magnitude, right? So the magnitude are equal, but the direction of C is not equal to the direction of D. Right? So this is very important to understand. Therefore, since this is not the case, then therefore, this is how we write therefore. So therefore, vector C is not equals to vector D. Right? But in this one, where they are equal, is a situation whereby I have vector C going that way, and vector C is 20 meters. Then let me say I have vector D. Vector D is also pointing that way and is also 20 meters. Then these two vectors are the same, right? So this is this case here. So these two vectors are the same, and then this is this case here, and then these two vectors are not the same. So it's very important that you understand these two concepts when a vector is equal, when a vector is not equal. So if you look at this vector and this vector here, I drew them. I know they are not exactly the same, but I drew them such that this vector here is the same magnitude and they are both pointing in the same direction. Therefore, these two vectors are actually equal. Alright, so let me just try and remove everything that I have here. It's going to take some time because I'm just undoing everything. So let me see if I can undo as much as I can. Seems like I can. It's going. Alright, so it's very important. So it means that that vector here, I can actually translate any vector and I can put it anywhere, right? As long as I don't change the magnitude and as long as I don't change the direction, it's still the same vector. You can go home with it, I would say, right? As long as you have not changed the direction and you have not changed the magnitude, you still have the same vector, right? So that's what basically we are saying. So it seems like I went back too far. So let me try and get everything back. And sorry about that. It's taking time, and these are the joys of trying to teach everything live. Alright. Okay, not the joys this time, it's pains actually. See, now everything is coming back in a way that I don't like. Alright, so should have used the erase. Would be done by now. Okay. Alright, so I can do the same with this vector. I can take this vector and I can put it here. I draw a vector from here in the x direction and then it stops there. This is still the same vector as vector A. Right? So I think you get the idea of what is happening here. Alright, now I'm going to do the same thing. But then what I'm going to do is I am going to move this vector B and move it somewhere here. Because remember, what I want to do is I want to find out how can I add these two vectors. That's basically what I want to find out. Is it possible for me to add these two vectors? Alright, so what I want is I want the vector C such that vector C is vector A plus vector B. So it's a sum. Now whenever you're looking for a sum of something, then we call the sum. So the sum of all the vectors, whatever vectors that you're summing, let's call this vector A. The sum of all vectors is called the resultant. You can call it the resultant R. Alright, so these are called the resultant. So whatever sum you get is a resultant vector. Right, it's a vector resulting from adding all those vectors. That's how you can actually think about it. Alright, so when it's like this, what I will do is I want to draw vector A. So there's vector A. Alright, then I want to add it with vector B. Right, so I'm doing it the other way around, but it's fine because I'm labeling. I mean, in terms of the colors. So I want to add, so I draw from the tail to the head of A. Now from the head of A, I must draw the second vector, which is this vector B according to the equation. So this is vector B. Now what is my resultant? My resultant is always from the tail of the first vector. The first vector is A. So the tail of the first vector to the head of the last vector. Because you can have like hundreds of vectors. You could be adding hundreds, 2, 3, 4, 5 vectors. It doesn't matter. Right? Whatever the last vector is, go to the head of that last vector. So if you draw a line between those two dots here, then whatever you find, that is actually the resultant vector. In this case, we call this vector C. Now you would notice something. You notice that these three vectors are forming a right angled triangle. And since they are forming a right angled triangle, we know a couple of things with the right angled triangle. So let's see what is it that we know about the right angled triangle. So I can remove all of this stuff about vectors and then just take it from there. Alright. Okay. So what do we know about the right angle triangles? Okay, I'm trying to choose which color. Let's go with blue now. I think blue is gonna go well. Alright. Now, because I have it, I chose it here, but it's fine. I'm just going to choose blue. Now, let me say I have a right angle triangle. There's my right angle triangle. What do I know about the right angle triangle? Now, the longest side is called the hypotenuse. This side is called the hypotenuse. Right? And then this is, if I have an angle theta here, the side that is just next to theta is like a next door. Think of it like a next door neighbor. It's called the adjacent side. That's what your adjacent means, just next to you. That's adjacent. Now, if you were to draw a line and then from the angle and then to this side is opposite the angle. So this is called the opposite side. Now, from this we know, so if I call this side R and I call this side Y and I call this side X, right? So we know that if we want the magnitude of that, we know that according to Pythagoras, R squared is going to be equals to X squared plus Y squared. So if I wanted to find the magnitude of the hypotenuse, I'll just have to say this is going to be the square root of X squared plus whatever Y squared is. Okay. If I wanted to find the direction, I would just use the tan of theta. I'll say the tan of theta is opposite, which is equals to y, over the adjacent, which is equal to x. All right. So this is how we are going to find the magnitude of all resultant vectors. This is how we are going to find the direction of all resultant vectors. Now, this is when the vectors that we are adding are going to be perpendicular. All right. Okay. So this is good. Later on, I'm going to reduce each and every vector that I see. I'm going to make it into an x and a y component, but I'll get into that when I get there. So at the moment, I'm just adding vectors that are perpendicular to one another. Okay, so which means here, I'll have an angle theta here. All right. Now, so it simply means that when I want the magnitude of this vector, so if I want the magnitude of vector C, now if you look at this triangle, it's a right angle triangle. So if you look at this triangle, this side is the longest side of the triangle. So it's the hypotenuse. It represents this hypotenuse. So think of it like R. If you look at this side, it's the side opposite to the angle. Think of it like Y because it's on the Y-axis. You see it's vertical. It's on the Y-axis. This side is the one that is just adjacent. It's next to the angle. Now, it's not all the time that the angle will be here, but then I'll probably make examples whereby the angle is not there. So, and then you can actually think of it, this is the adjacent side. All right, so the question is, how do I find the magnitude? Well, the magnitude of C, according to what I said, is going to be given by the square root of whatever it is on the x. On the x is A, so the magnitude of A squared, so I'll just write it as A, and the magnitude of B squared, I'll write it as B. All right. Now, in some books, for instance, you'll see something like this, whereby they'll say it's a magnitude of A and then squared plus the magnitude of B, and then they are squaring it. So they just mean the magnitude. It's the same thing. I'm using the same thing. The notation is just different. All right. So this is good. And so that I don't forget, because I want to move, so I know that my A is going to be 30 meters. It's in the x direction. That's my vector A. My vector B is going to be 25 meters in the y direction. All right, so now I can actually move this out of my sight, basically. All right, so remember we are still looking for C is equals to A plus B. So in order for me to find the magnitude of C, I just need to know what is the magnitude of A, what is the magnitude of B. Now from this, I mean the magnitude of A is 30, the direction is X. Here the magnitude is 25 and then the direction is Y. So C is going to be equals to the square root of 25 squared, 30 squared so I don't confuse you. It's 30 squared plus 25 squared. Alright, so this is A squared plus B squared, just the magnitude. Now it doesn't matter, I mean even if you had a negative here, it doesn't matter, because when you square anything, even if it's negative, it's going to be positive. So just put the positive numbers, don't ignore the negatives when you're substituting for the magnitude. Alright, so there's C, And then let's find out what is going to be the magnitude of C. Alright, so the magnitude of C is going to be the square root of 30 squared plus 25 squared, and then it turns out that the magnitude is about 39. So I find that the magnitude is going to be 39 meters. So this is just the magnitude, this is not a direction. So I still need to find the direction. What is the direction? The direction is going to be 10 of theta, and then this is going to be whatever the size of the opposite is. This is the opposite side, so it's B. And we know from here, B is 25. So even if it's negative, don't put the negative. So when you see negatives here, even these vectors were negative, don't put any negative. Just substitute everything as positive. And then it will make sense later when I explain. Alright, and then what is x? Remember that the tan of theta is going to be equals to the opposite side, which is B, divided by the adjacent side, which is A. Alright, so what is B is 25, what is A? A is 30. Right? So, and then what you're going to do on your calculator to find theta, you are going to hit shift if you're using the same calculator as mine. Going to say shift, and then you say tan is going to do this. Then you open the bracket and say 25 over 30. Then you find what is the angle there. Alright, so and make sure that your calculator is in degrees for those of you that do sometimes use calculators in other forms. If you don't understand anything that I've said now, just don't worry about anything that I've said. Alright, so it turns out that the angle is going to be 39.8 degrees. Alright, so that's what theta is. So this is the direction, and then this is the magnitude. Now, how do we write this thing? Now, you have to follow me as to how do we write this thing. Now, this is how we write this thing. We say, okay, fine. I have a vector C, and vector C is like this. This is how my vector C is. Right from here. I mean, you can see from here, vector C is like that. Alright, so this is vector C. And I have an angle here of 39.8. Right, that's the angle that I found. Alright, now the question is, how do I then describe this in words? Right, I want to describe this in words. So how do I achieve this angle? Well, if you look at this, you must go to the east first. When you get somewhere here, you stop. Then afterwards, you go to the north. And then you're actually going to create this vector C. Right, that's how you got this vector C. You first went to the east, then you turned, and then you went to north, and then to north. So how you write this answer is you say C is 39 meters, comma, 39.8 degrees. Now you went from east to north, but when you write it, you are going to say north of east. So when you write like the off, when you put this word off, just swap these things around. So if you went first east and then change to north, then when you write them, just say north of east, and then it's going to make your life easier. Another way you can say the same thing. You can use the same thing. Remember that we have the Cartesian plane, the x and the y. So you could say that. You could use that. All right. So you could use that, and then say, okay, fine, I'll use my unit vectors. So this is x hat. Now, if you can see this, this is above the x direction, right? So you could say C is 39 meters, 39.8 degrees above the positive x-axis or x direction. If you want, it's still fine. Right, you could say x direction, or you could say x-axis, is still fine. We'll understand what you're trying to say to us. Right? So you could say that if it was below, like if it was somewhere here, you'd say below. Then if it was on negative axis, you say above the negative or below the negative. If it was somewhere here, you say to the left of the positive x-y axis, or to the right of the positive y-axis, or to the left of the negative y-axis, to the right of the negative y-axis. Then we know what are you telling us about where the angle is. All right, so hopefully guys this makes sense. So that I don't confuse you further, I think this should be fine for me to stop for this video. It's long already, and then I'm just going to continue in the next video. So I'll see you guys next time. Cheers.